Question number 2 from the differential equations in linear approximation worksheet says we have the derivative is equal to y minus x squared, and it has a point, initial point at 2, 5. So this derivative goes, the solution to this differential equation goes to the coordinate x equals 2, y equals 5. And it asks to approximate the value of y when x is 2.1. So one thing to note is that this differential equation cannot be solved. Okay, we cannot, well, it's not that it couldn't be solved, can't be solved. We aren't able to separate and integrate this equation. So we can't actually find the general solution, but we can approximate values on this function by, first of all, coming up with a linear equation. So that's the first thing I'm going to do. So I'm going to find the slope. So dy by dx. When x is 2, y is 5. Plugging that in, I get 5 minus 2 squared. So the slope is equal to 1. I have the slope. I'm going to write my linear approximation equation as 1 times x minus 2 plus 5. Okay, this is put in my point slope form. There's my slope. There's my x and y coordinate. Now if I want to approximate the f of 2.1, we know that this is approximately going to be equal to the point on the linear equation. So it's going to approximate L of 2.1. So all I'm going to do is plug in my 2.1. I get my run, which is the difference between the coordinate of tangency, is just 2 and 2.1. So I get 0.1 times my slope plus the y position of that initial point, and we end up with approximately equal to 5.1. Okay, so f of 2.1 is approximately equal to 5.1.